Welcome to my video. The topic of today's video is to use balloons to show electron group geometry. And to accomplish this, we'll use the Vesper theory, which is the valence shell electron repulsion theory, which is basically a model that uses three-dimensional shapes to show opposite attraction, repulsion of electrons from the central atom. And for today's video, we'll be using balloons as my model, as you can see here. So we will first start with two electron groups. So here is one electron, and here's two electron. And like right here in the middle, that's the central atom. We can literally think of it as, the central atom being A and the two electrons being B. So these two electron groups around the central atom, they take opposite positions, from each other. And based on this, it has like sort of a straight line. So this means this is a linear electron geometry. And the bond angle, which is basically, the bonding of this to the central atom, is 180 degrees. Now for bond angles, they do want to take like that perfect circle, which is 360 degrees. So that's 180. So a straight line, that's 180 here, 180 there, which is 360 degrees. Now moving on to the next, we have three electron group or domain. The wording doesn't really matter in this sense, but we have three electron group, and again, let's say this is B, and the central atom is A. We have 1, 2, 3, right? And this is taking the shape of a triangle. We can sort of see that triangle shape right there. So this is called a trigonal planar electron geometry. Takes the shape of a triangle, which is the tri, and then the planar, which is basically like the shape. So this is the three electron geometry. Now the bond angle for this is 120 degrees. So 120, 120, 120, which makes 360 degrees total. The next that we will move on to is four electron group. So right here, you can see four electron group, right? So this is the four electron groups, and this shape is called tetrahedral. 1, 2, 3, 4. Tetra, which is 4, and hedral basically means shape. So this isn't as perfect as the trigonal planar. So the bond angle is less than 120 degrees, and the bond angle for this is actually 109.5 degrees. So the next one we're going to move on to is now we're going to talk about the fifth electron group. And based on the balloon, as you can see here, 1, 2, 3, 4, 5, it has 5 different electrons away from the central atom in the middle. So this electron group is called the trigonal bipyramidal electron geometry. And the reason it's called that is because it has 1, 2, 3 tri, as a triangle, and sort of the shape as well, a triangle. Bi for like the two, it is 5, the two that are left, and then pyramidal because when you put it, when you hold it, the bottom takes the shape of like a pyramid. So it's called like a tri-bipyramidal electron geometry. So now, this shape is a little bit special in the sense of it has two different positions which affect its bond angle. If I hold it like this, if I hold it like this, there is this, part here, and then this part here. So this part, from top, sort of top to bottom here, well, not from like here, it's called the actual position, not really top to bottom, but then this part here is called the equatorial position. So this equatorial position gives it 120 degrees, while this actual position gives it 90 degrees. So, you know, it does have, you know, different bond angles, the 120 degrees here and the 90 degrees in the actual position. So, you know, this is the fifth electron group for the electron geometry. So our final electron group is called the octahedral electron group. And, you know, as you can see here, it has 1, 2, 3, 4, 5, 6. It has 6 electron geometries. And, you know, all of them are like sort of even. So, and by even, that means the bonding pair for all of them is 90 degrees. So all of them have a bonding pair of 90 degrees for the octahedral, which is the electron geometry of the 6 electron group. So, you know, that's the video for all of the different electron group projects. So as you can see, you know, it has 6, 2, and all the rest. And, you know, that specifically shows electron geometry. Now, molecular geometry, which is like the actual, you know, shape of the modules, it goes into more specifics, like what happens when there's like lone pairs and like how the shape will change. But, you know, for the topic of today's video, it is specifically electron geometry. So that just the video I've shown so far, you know, shows the 6 different electron groups that we have, you know, starting from the linear electron geometry, the trigonal planar electron geometry, the tetrahedral electron geometry, the trigonal bipyramidal electron geometry, and with the last 6th electron, the octahedral electron geometry. Thank you very much, you know, for staying for the video. I'll see you in the next one. Bye.